Good morning. Namaste. I take this opportunity with pride to introduce our speaker for today's webinar, Mrs. Sreedevi, Principal of Telangana Model School and Government Junior College, Shankarampet, Medak District. Madam is a seasoned teacher with a streamlined presentation skills. She has got an experience of around 30 years teaching mathematics and at various levels from KG to PG. She's a passionate teacher and takes the same pleasure and pride in teaching a child, whether he's in the class 5 or at PG level. Only it matters that she teaches mathematics. So such a passionate teacher. So we are going to have a session on Maths 1B, transformation of axis. And this is a very easy chapter, interesting chapter. So over to Sreedevi ma'am. Madam, please welcome.
Thank you so much, Krishna Kumar sir. Thank you so
ma'am.
much for the kind words. It's an honor for me to get introduced by you, sir. Namaskaram, everyone. I'm so happy today. I take this opportunity to thank our additional director, sir, joint director, sir, the team of webinar, TSMS webinar, for giving me this opportunity. And most importantly, I thank all my students who are eagerly waiting to go through this lesson. Students, you have been learning mathematics from childhood, isn't it? Is it the same way that you learn in primary session as well as when you come to high school and now when you are in junior intermediate? Hasn't it changed? It has, right? So today we are going to learn about transformation of axis from Mathematics 1B chapter. What is transformation, children? You all know, isn't it? It is just change. Change in any form is transformation. Oh, change is the law of nature. Everything in the nature keeps changing, keeps transforming. Then what does transformation of axis mean? What are axes? Oh, coordinate axis, right? You all know. You know about x-axis, you know about y-axis. You have been using them from class 7, 8, isn't it? So how does the coordinate axis change? What does it mean by transformation of axis? We are going to learn in today's topic, that is transformation of axis. What kind of changes that we can expect? See what is happening to this coordinate axis? Oh, they are moving, they are changing. We know the horizontal axis is called x-axis, the vertical axis is called, number line is called y-axis. They are mutually perpendicular number lines so that their zeros coincide. The point of coinciding, that is the intersection, is called origin. These all things you have learnt in your previous classes. How they are changing now? See, when I am moving them, they just keep moving without changing the horizontal and vertical position. We call this translation. The origin is not changing. It is at 0, 0 only. But the axis keep moving without change of the direction, only with the shifting of origin. That is called the translation of axis. Then only when the origin is shifted, this is another set of coordinate axis. Oh, the origin was moving, they were fixed in translation, isn't it? Now when we are looking at the second one, see what is happening. Oh, what is happening? The axes are rotated, isn't it? Rotation is taking place. without changing the origin. Oh, these two are the only changes in what we see. We can see that the both translation and rotation can take place at a time. You can see this translation and rotation. The direction of the axis is changing, as well as the origin is also shifting from one place to other. We have translation and rotation both in the third case. So transformation of axis is what? It is nothing but translation, rotation, translation and rotation. So children, now you must have understood, okay, sometimes we are shifting the origin, sometimes we are rotating, and again we are doing both. What will happen? Before getting into knowing what will the transformation of axis really mean and what changes it does it bring in the position of the points and curves, let's recall what you already know in today's topic translation. Recollecting to that, what do you know? You already know about rectangular coordinate system, isn't it? What is rectangular coordinate system? Two mutually perpendicular lines we have seen, and when you call them axis, obviously, and the plane is divided into four parts called quadrants. And when a point, position of a point, how do you denote? It is denoted by an ordered pair. What's an ordered pair? X comma y in general. That means where x is the first coordinate and y is the second coordinate, x, y are called coordinates. This is a basic knowledge that you already have. You all know about it, right? This is our horizontal number line, x-axis, and this is our vertical number line, x-axis and y-axis. And how the plane is divided into? It is divided into four quadrants. Quadrant 1, 2, 3, and 4. Then, what is the point of intersection of these are axes? You all know. It is origin. So, origin is nothing but 0, 0. Now, we have seen that a point, if I take a point here, we denote it with coordinates x comma y. What is the value of x and y? How do we know? Oh, 4 comma 3. How do we get 4 comma 3? 4 units on x-axis, 3 units on y-axis. The point is 4 comma 3, isn't it? Now, if I'm looking at this axis, if the position of this point is changed, I'm just keeping the axis without any change. If I'm changing the point from there to here, what is happening? I'm moving the point. What will happen to the coordinates? They also keep changing, isn't it? Now it is 5 units and 1 unit on y-axis, so the point is 5 comma 1. What happened? The point from 4 comma 3 has changed to 5 comma 1. What do we notice? When the position of a point is changed with respect to coordinate axis, then the coordinates of the point also changed. From 4 comma 3 to 5 comma 1, the coordinates have changed. That's what we noticed. Now, if at all the position of the point is not changed, I mean I will leave 4, 3 there only, but position of the axis is changed. I'm changing the axis either by rotation or by translation. Will the coordinates of the point remain unchanged? Let's look at it. That means, will there be any change in the coordinates of the point, or will the point remain unchanged? Let's look into it. Again, for that, we'll take x-axis and y-axis. So, we take a point origin and then this point, same, 4 comma 3. What did we discuss about translation? The axis keep moving, changing their position or shifting without changing the direction. See, now this point is 4 units and 3 units. In the previous example, we have seen what happens to the coordinates of this point if this y-axis is changing or x-axis is changing its place. Let's see. Yeah, this is the point 4 and 3 units, 4 comma 3. Now I'm going to change what? Shift y-axis. Let us look at the point coordinates. How many units are there on y-axis? Same, 3 units. So y coordinate remains unchanged. To which point did we move the origin? 5, 6. Say 6. 0, 6, 0. So what happened to the x coordinate now? From the original y-axis, what is the distance? 4 units. But from the new axis, what is the distance? It is minus, isn't it? Minus 2 units. So 2 units distance, and we denote it as minus because it is on the left side. But the difference that I am talking about is 4 minus 6. Concept is y coordinates are not changing, x coordinates are changing when I am shifting the y-axis. And similarly, when I am shifting the x-axis, what happened? The point here will have same 4 only, but probably the y value is only 1, isn't it? Y coordinate remains only 1. That's how the coordinates change, and accordingly the coordinates of the point also change when you move x-axis alone or y-axis alone. That is one kind of translation. What if both the axes are moving? Now x-axis, y-axis the same thing. We have 4 units and 3 units, 1 unit. So the point is 4 comma 1. Now what happened? What happened, children? I'm just shifting the position of both the axes. So this point 4 comma 1, which is there, it remains there. But the coordinates will not remain 4 comma 1. What will happen to them? Let's see. How much is this unit? 1, and then this is 3. So the new coordinates are 1 comma 3, isn't it? So what do we notice here? We have shifted. The process of shifting these axes without changing the direction is called translation. And what will happen as a result? When the axes are translated, the coordinates of the points will be changed. That's what we have noticed, isn't it? Translation is the process of shifting axes without changing the direction. What is changing now? The origin is being shifted, but horizontal x-axis, vertical y-axis remain in their direction only. Am I clear, children? Okay. Now, let's see. In general, if I'm taking a point x comma y and origin is 0, 0, I am choosing a point h comma k. Why am I doing? Earlier we have taken 4 comma 1, 1 comma 4, 4 comma 3, all those points, it's easy to understand. But is it common for every point that we take? In general, if we take a point x, y, we don't know what is the distance. H comma k is the new point where I want to shift the origin. I am shifting the origin from 0, 0 to h comma k. In this translation, what are the new coordinates? The new coordinates of the point will become capital X comma capital Y. Small x, y were original coordinates, and the coordinates in the new system are capital X and capital Y. When the origin is shifted to h comma k, what happens? The original coordinate small x, y change to capital X, capital Y. What is the origin shifting from? 0, 0 and to where? To h comma k. Now, what is note? Sometimes not only capital X, Y, you can also denote the new coordinates as x dash comma y dash. So either you use capital X, capital Y or x dash y dash, they denote, they represent new coordinates. Coordinates according to the translation with reference to the new axis when the origin gets shifted from 0, 0 to another point, say h comma k. Now, okay, what kind of, how do we find? If it is 4, 3, if it is 4, 1, 5, 3, in any way you can change, you can see what was the difference. But in general, if origin is 0, 0 and the general point is xy, if I'm taking this point xy, what does it mean? The x coordinate is x, the distance from origin to this point, the perpendicular distance from here to here is y again. So this is y, this is x. We all know about it, isn't it? The first coordinate, x coordinate, is the distance from 0 to the foot of the perpendicular on x-axis, and this is y. Obviously, you know this. Now, let's choose an arbitrary point h comma k and shift the origin from 0, 0 to h comma k. What will happen as a result? See how much distance is this? H comma k means from origin to this point the distance is h, and from origin to this line the distance is k. Clear, children? You know this. These are all basics that you already know. Now, what are the coordinates in the new system? Capital X, capital Y. So what does it mean? What is capital X? From new origin till here, isn't it? That is capital X. And from new origin till here, it is capital Y. Can we find some relation between the new coordinates and old coordinates with this? I think you can see the old coordinates a little faded and the new coordinates bright and red. Okay, let's see. From here to here, if I see, the distance is x. But what it is equal to? It is equal to same as from this point to the new coordinate. What is this distance? X, capital X. What is this distance equal to? Small h, isn't it? So, if I am bringing this x here and bring this h and put this capital X. Oh, when they together are taken, capital X plus H, they are equal to small x. You can see that in the diagram as well. From here to here, if I am taking the distance, it is nothing but you are adding this distance plus this distance, isn't it? This distance is h, and from here to here, it's nothing but capital X. So, what is the observation? Small x is equal to capital X plus capital H, small h, capital X plus h. In the same way, what is y equal to? Capital Y plus k. This is what you need to remember, students. This is going to help you in solving the problems. What is this? This is an equation in three unknowns, isn't it? X, capital X, H, Y, capital Y, and K. So three coordinates are there, 3 points are there. If you know any two of them, it is easy to find the third one. I mean, if you know old coordinates, original coordinates, and the origin to where the point is shifted, h comma k value, then you can find the new coordinates. If you know these two, you can find the origin. If you know new coordinates and h comma k, you can as well find xy. So this is the relation you need to remember, very, very important. Original coordinates is equal to new coordinate plus h, and original coordinate is equal to new coordinate plus k in case of y. I hope you will make a note of this, children. Please make a note of this. Now, okay, what is the relation? That's what, again, for you to have an idea and to note it down. See, I'm putting it bold and clear. Small x is equal to x plus h, y is equal to capital Y plus k. Or if I want to find the capital X, what it is equal to? That is x minus h. Capital Y will remain same. And if I bring k to this side, it will be y minus k. These are the, now from this, don't you think you can find out h also? H is equal to small x minus capital X. K is equal to capital Y minus small y. So what is the relation between these? What is going to happen when origin is shifted to h comma k point by translation of axis? Then the coordinates of the point p x comma y are transformed as capital X, capital Y. What is capital X? X minus h, x minus h. What is capital Y? Y minus k. So the points change to x minus h, comma y minus k. And equation, see, you have drawn so many equations in the coordinate plane. You have seen it in your earlier classes. You have drawn straight lines. You have drawn a curve called parabola in class 10, isn't it? So all those equations of curves, the equation f of xy is equal to 0 of the curve is transformed as f of, what is small x? Capital X plus h. What is y? Capital Y plus k. So please make a note of this equation. From this you can derive the other two easily. Right, children? Now, after knowing what is the relation between these three, let's apply that in solving the problem. Okay, when the origin is shifted to 4 comma minus 5 by the translation of axis, find the coordinates of the point minus 2 comma 4 with reference to new axis. Children, what we need to understand are in any question given, what is given in the problem? First thing we have to find out what is given here. Origin is shifted to 4 comma minus 5. That is given. So according to our formula, one point we got. What is this point? Is it xy or capital XY or HK? When the origin is shifted to 4 comma minus 5 by translation of axis. Obviously it is h comma k. What is given? H comma k is 4 comma minus 5 is given. So you know h is 4 and k is minus 5. I need not tell you that. Now what else is given? Find the coordinates of the point minus 2 comma 4 with reference to new axis. So you are supposed to find the new axis, reference point with reference to new axis. New coordinates are to be found. Given are original coordinates. That means small xy or capital XY. Small xy is equal to what is given? Minus 2 comma 4. So obviously x is minus 2 and y is minus 4. Then what do you have to find? You have to find the new coordinates. New coordinates are nothing but capital X comma y. Oh, let's recollect what was capital X, capital Y. Small x minus h, small y minus k. You need a little practice only with this formula. The entire chapter is based on this. The translation is based on only this. Okay, children? Okay, let's substitute. Small x is minus 2. My h is 4. Minus 2 minus 4 is minus 6. Simple. Y is equal to y is 4 and minus of minus 5 plus 5. 4 plus 5 is 9. What are the new coordinates then? Capital XY is equal to minus 6 comma 9. Hope such simple problems need not be explained again, isn't it, students? You can do it just orally and tell me the answer. I know you're very smart. Okay, only thing you need to be careful is identifying the original coordinates, new coordinates. What is given? What do we need to find out? Okay, we found the new coordinates when original coordinates are given. Can we do it the other way? I mean, when the new coordinates are given, can we find the original coordinates? Let's take an example and see. The second example that we are going to see is when the origin is shifted to 2 comma 3. Obviously, what is 2 comma 3? H comma k. By translation of axis, h comma k is 2 comma 3. Find the coordinates of p. The coordinates of the p change as 4 comma 5. What is given? The coordinates of a point P change as 4 comma 5. Means these are changed coordinates. Find the coordinates of P in the original system. Let's see. H is 2 and K is 3. What is given? Capital XY is given because the coordinates of P change as 4 comma 5. Capital X is 4, capital Y is 5. Now we have to find the coordinates in the original system, that is small x, y. Again, what is small x? Capital X is equal to x minus h. What is small x? X plus h. Capital Y is equal to y minus k. What is small y? Y plus k. So x is equal to, what do you get? Capital X is 4, h is 2. 4 plus 2, 6. Y is equal to y, capital Y is 5 plus 3, 8. So what are the coordinates in the original system? They are 6 comma 8. Students, we have seen how to find coordinates in the new system. How do they change to the new coordinates x comma y when original system coordinates are given? And we have also seen how to find the coordinates in the original system when the changed coordinates are given. Now, we were also discussing a point, isn't it, children? Not only points, when you join points, you get curves, you get straight lines. You get parabola, you get hyperbola, you get a circle, you get a triangle. Many other things are formed, isn't it? Even in your coordinate geometry, you have seen that. You have found the area of triangle also in coordinate geometry, isn't it? So now we are going to shift from just finding the changed coordinates or original coordinates. We are going to find the equations and what sort of changes do they undergo and in translation. For that, I'm going to take another example. When the origin is shifted to -1 comma 2 by the translation of axis, find the transformed equation of what is given here. We are given with an equation which is x square plus y square plus 2x minus 4y plus 1 is equal to 0. What are we asked to find? Find the transformed equation. What does it imply? This is this equation in the original system. Am I clear, students? We have to analyze. First, read the question carefully and analyze. Find the transformed equation when it is asked. You are asked to find the transformed equation. So, given equation is equation in the original system of axis. Let's see. The solution given is h comma k, that we know. When the origin is shifted to a point, we take it as h comma k, isn't it? So h is -1, k is 2. Now, the equation in the original system is given. When you are finding transformed equation, what does it mean? Given equation is in the original system. X square plus y square plus 2x minus 4y plus 1 is equal to 0. Now we have to find the equation in the new system. To find that, we have to use the formula again. What is that? Capital X is equal to x minus h. Capital Y is equal to y minus k. Isn't it? But what we are going to do? We are going to put small x is equal to x plus h. Small y is equal to y plus k. So small x is equal to x plus h. H is how much? Minus 1. X minus 1. Small y is equal to y plus k. K is how much? Y plus 2. Are you able to follow, children? I have to replace this small x. Small x is equal to what? Capital X minus 1. Why? H is minus 1. Capital small y is equal to y plus k. K is 2, so plus 2. Let's substitute these two values in the given equation. The equation is written here. Instead of x, what am I writing? X minus 1 whole square plus y plus 2 whole square plus 2 into small x is x minus 1 minus 4 into y plus 2 plus 1 is equal to 0. This is simple for you. You know what is this form? Right. This is a minus b whole square. A square minus 2ab plus b square. What is this? This is a plus b whole square. Y square plus 2 into 2 into y. 4y plus 2 square is 4. Just multiply, eliminate the brackets. 2x, 2 into minus 1 minus 2, minus 4 into y minus 4y minus 4 into 2 minus 8 plus 1 is equal to 0. We will write it in the standard form again now and simplify. What do you notice here? This is minus 2x. Any other x term is there? This is plus 2x. What do you think, children? We can cancel them. Plus 2x and minus 2x becomes 0. Similarly, you have 4y and minus 4y. Can we cancel them? Of course, yes. What's remaining? Capital X square, capital Y square, and you have all the other constants. So x square plus y square. What is the constant value? How do you find? 1 plus 4, 5. 5 plus 1, 6. 6 minus 8 raised to 10. 6 minus 10 is minus 4. So what is this? This is the transformed equation. That's the required transformed equation is. When we have found the equation, which is transformed equation, which has to be written in capital X, capital Y, isn't it? But you can as well replace these new coordinates with small x, y when you are writing the final step. Final answer can be left like this, may be written like this. Both are correct. Don't get confused. I am finding only the transformed equation. But what am I doing? I am just writing it for convenience in the form of original coordinates. Whenever we look at an equation, we write small x, small y square, isn't it? That's the reason. So when the origin is shifted to -1 comma by 2 by the translation of axis, the given equation is transformed to x square plus y square minus 4 is equal to 0. You will learn that this represents a circle in your second year students. Okay. This is the question which is asking you to find the transformed equation. Original equation is given. Now we will see an example where we are given with the transformed equation and we shall try to find the equation in the original system. Okay, let's see the example. If x square plus y square is equal to 4 is a transformed equation when the origin is shifted to 3 comma minus 4 by the translation of axis, find the original equation. After reading the question, what do we need to do? We have to analyze and find out what is given. What is given? X square plus y square is equal to 4 is the transformed equation. Means equation with respect to the new axis when the origin is shifted to 3 comma minus 4 translation of axis. So this value is what? Origin is shifted to this point. Obviously it is, what is it? H comma k, you're right. So when the origin is shifted to 3 comma minus 4, the transformed equation is given. Look at this, children. The transformed equation is given in small x and small y, but we know transformed equation is represented with capital X and Y, isn't it? Let's see. You're asked to find what? Original equation. Now h comma k, 3 comma minus 4, very easy for you. H is 3, k is minus 4. What else is given? Transformed equation is x square plus y square is equal to 4. What does it imply? I will write it in capital coordinates, isn't it? Capital X square plus capital Y square is equal to 4. In order to make the substitution and to avoid the confusion, what am I doing? I am just writing the transformed equation using capital coordinates. We have to find the original equation. What is the formula? Same. Capital X is equal to x minus h. Capital Y is equal to y minus k. X minus h value is how much? 3. Y minus k value is how much? Minus 4. Y minus of minus plus 4. So we have to replace capital X with x minus 3, capital Y with y plus 4. In the given equation, what is the given equation? X square plus y square is equal to 4. What am I writing in place of x? X minus 3. What am I writing in place of y? Y plus 4. So the equation becomes x minus 3 whole square plus y plus 4 whole square is equal to 4. Again, a minus b whole square, a square x square minus 2ab, 2 3s are 6x plus b square, 3 square 9. This is a plus b whole square. You are very familiar with. Let's simplify. X square minus 6x plus 9 plus y square plus 2 into 4, 8y plus 4 square, 16. What happens to this 4? I'm bringing it to the left. It becomes minus 4 is equal to 0. We have an x square term, a y square term, one x term, one term containing y, and the constant. So x square plus y square minus 6x plus 8y. 16 plus 9 is 25. 9 plus 16, 25 minus 4 is 21. So the final equation is x square plus y square minus 6 plus 8y plus 21 is equal to 0. This is the original equation, required original equation. Are you able to understand, students? What we have done? We have first taken the original equation in the third problem and transformed it according to the new axis. We found the transformed equation. In this problem, you are given with the transformed equation. We are finding the original equation. See, we have solved 4 types of problems so far. There is another problem also that I have not solved. I want you to solve finding h comma k. I have given it in practice session. We will discuss that. Now, a general equation is given. What is this general equation? We are going to another. See, origin is shifting. But what else? What are the other changes that it is going to bring in the equations of other curves? Always we do not have only straight lines, isn't it? So we have an equation here. What is this equation? It is a second degree equation. Let's see, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is a second degree equation in two variables x and y in the standard form, where x square is not equal to ab is the condition. If this condition is satisfied, this equation is going to represent a pair of straight lines. You have drawn one straight line separately, another straight line separately, and found out the solutions in earlier classes. In your class 10 also you have done that. Now this equation represents a combined equation. What is the condition? H square is not equal to AB. This equation in the general form also represents a circle where this H becomes 0. That means XY term misses. It becomes 0. It gets eliminated and A is equal to B. That means coordinate of x square is same as coordinate of y square. A is equal to B and H is equal to 0. If H is equal to 0 and A is equal to B, this equation is going to represent a circle. Students, you will learn about circles in your second year. So nothing to worry. You just have an idea that this can either represent a circle based on the given conditions or a pair of straight lines. But why am I discussing this? We were interested in only translation of axis, isn't it? When the origin is shifted to a point. Oh, I'm going to find out when the origin is shifted by translation to a point, what is the condition that we are looking at so as to remove the first degree terms? First degree terms are to be removed. Oh, translation is, this is the equation. So you get either pair of straight lines or a circle depending on the condition that satisfies. If we have to remove the first degree terms, why should we remove? In the process of homogenization and in other section when you solve the problems, sometimes we want to eliminate these first degree terms. First degree terms means x power 1, x term, the term containing again y power 1 y. Those two terms are to be removed. Now this is the original equation, and what is happening in the coordinate system? The axes are moving. In the axes are moving, what will happen to this new equation? See, we are all the time interested in the change, in transformation. How this equation will get transformed is our concern now. What will be the new equation? New equation should not have first degree terms. So, first degree terms should be missing. What are the first degree terms? 2gx and 2fy. We are discussing another concept wherein what kind of changes will happen in the transformed equation when we want to shift the origin from 0, 0 to another point by translation of axis, so that the first degree terms go missing, means they're removed from the equation, and what kind of a new equation is formed. We have to find that point. I have just shifted the coordinates, isn't it? Yeah, I'm shifting the axis. That means shifting the origin. To which point should I shift so that these first degree terms go missing? Let us find out how we can shift the origin from 0, 0 to this point so that the first degree terms in the equation go missing. In order to do that, say, what is this? What is the coordinates? That is the question, isn't it? Find the point to which the origin is to be shifted. I'm just going to find out to which point we can shift the origin. Let's see. See the same this thing in the solution. To which point? Should I shift it to 2, 1? Should I shift it to 3, 4? I don't know. I can take it as some AB. I can take it as some PQ. I can take it as any point. So I'm an arbitrary point. Let the alpha beta. I'm choosing an arbitrary point alpha beta. Let the origin be shifted to alpha comma beta by the translation of axis. Then what will happen? Oh, we have our own formula, isn't it? Small x. This is the original equation. You have to get the transformed equation, so you need to replace small x with capital X plus h. What is h? Alpha. Capital Y plus k. What is k? Beta. So x is equal to capital X plus alpha, y is equal to capital Y plus beta is the substitution that we are going to do in the equation. What happens? A into x plus alpha whole square, 2h into x plus alpha into y plus beta plus by square, b into y plus beta whole square plus 2g into x is x plus alpha plus 2f into y plus beta plus c is equal to 0. I repeat, see children, I am just replacing this small x with x plus alpha, small y wherever I have with y plus beta. So the equation is a into x plus alpha whole square plus 2hf of x plus alpha into y plus beta, b of y plus beta whole square, 2 times g of x plus alpha, 2f of y plus beta plus c is equal to 0. Now we can expand this, isn't it? This is alpha plus beta whole square. You can multiply this x into y, xy, x into beta, x beta, or beta x, alpha into y, alpha y, and alpha into beta plus alpha beta. Again, this also can be expanded using a plus b whole square formula. Simply you can eliminate the brackets, remove the brackets. Let's see that. See, a into a square plus b square plus 2ab, 2h into xy plus x beta plus a alpha y plus alpha beta, b into y plus b whole square, y square plus beta square plus 2y beta plus 2g into x, 2gx, 2g into alpha, 2g alpha plus 2f into y, 2fy plus 2f into beta, 2f beta plus c is equal to 0. Now, what is our aim, children? What is the condition that we have to fulfill to remove the first degree terms? So, wherever second degree term is there, wherever constant is there, I am not going to worry about them because my concern, my focus is to look for those first degree terms and see what do I get. So, let's see. Ax square is the a alpha square. Just expand, remove the bracket even here also. A x square plus a alpha square plus 2x alpha, 2a x alpha or 2a alpha x, whichever order you want to write, you can write. Not a problem. Usually we write the constant first. 2h into xy, 2h xy, 2h x beta, 2h alpha y, 2h alpha beta, by square plus b beta square plus 2by beta plus 2gx plus 2g alpha plus 2fy plus 2fb plus c is equal to 0. Now, we will not consider this ax square. We will not consider a alpha square. I am only interested in first degree terms. Wherever I have x alone or wherever I have y alone, I will consider. What is there? This is 2x a alpha. So I am going to consider this term. Xy term not needed. 2h x beta, yes, only x is there. I'm going to take that. 2h alpha y first degree term. We will consider that y power 1. 2h alpha beta, all constants, don't need. By square second degree term not necessary. B beta square constant, we don't need it. 2y beta b. This again has y power 1 first degree term. We will take it. 2gx, of course, first degree term. 2g alpha constant. 2fy first degree term. 2f beta constant, and c is also constant. That's equal to 0. So what we are considering, our aim is to remove, if this equation has to be free from the first degree terms, if I have to remove the first degree terms from the equation, what do we have? We have 2x, we have already discussed it, 2x alpha a plus 2h x beta plus 2h alpha y plus 2y b beta plus 2gx plus 2fy is equal to 0. I'm going to take this in the next slide as well. Just repeat this in the next slide. See, this is what we have. The last step is this. Now, if you look at this, you have 2x, and in three terms, 2x, here 2x, here 2x. Can I take 2x common? Yes, I can take 2x common here and here and here. These three terms, what do I get? And in the other terms, I can take 2y. If I take 2x common, if I have to remove means what? In order to remove, I have to equate them to 0. Now I am taking out 2x common, the variable. Here it is alpha a, here it is h beta plus 2x is gone. What is remaining? G is remaining. Now, if I am taking 2y common, what is remaining here? H alpha, 2y common, b beta or beta b plus 2ay common, f is remaining. Now, x is a coordinate and y is a coordinate too. If you bring them 0 by 2x, 0 by 2y, they become 0. You all know that. A alpha plus h beta plus g is equal to 0. H alpha plus b beta plus f is equal to 0 is what is going to remain, isn't it? Are we not going to get this? Yeah. A alpha plus h beta plus g is equal to 0. H alpha plus b beta plus f is equal to 0. Students, you have learnt about pair of linear equations in your class 10. Of course, they were not having alpha beta, they were in ax plus by plus c is equal to 0 form, isn't it? Here instead of xy, what do you have? We have alpha comma beta. These two equations can be solved using different methods. What are the methods, students? You have learnt in class 9 and 10. You can solve them using substitution method. That means you take one variable value from one equation and substitute in the second equation. That is called substitution. Either alpha is equal to, you substitute, or either beta is equal to something, you substitute here. Or you can eliminate one of the variables by equating the coefficients. How do we equate the coefficients? This equation should be multiplied by h. This equation should be multiplied by a. So ah alpha will get cancelled when you subtract the equations. Then you can find the value of beta, isn't it? That was the process, which you already know. Or you can draw the graph and plot the points and see where the two equations meet, and that point of intersection is taken as a solution for this equation. Why am I going to solve? What is my aim? What did we start the question with? We have started the question with, let alpha comma beta be the point to which the origin should be shifted. But what is alpha beta? We have to find that alpha beta. So when can I find alpha beta and how can I do that? I can do it in using various methods. Today, students, you're going to learn something new. We are going to solve these linear equations in two variables using a cross multiplication method. This method you will be learning in your next chapters also, straight lines and pair of straight lines also. That before going to that topic, I want to give you an idea how the cross multiplication can be used in order to solve the linear equations. Let's see. What are the variables, students? Here alpha, here beta. What is the variable? There is no variable. So we consider it as 1. Now, when I am taking alpha first, beta then, and 1, I should not consider the coordinates of alpha. What do? I take h, g, a, and then repeat h. What am I talking about? I am considering the coordinates. Coordinates are what? Coordinates of beta. What is the coordinate of beta? H. What is the coordinate of 1 here? G. What is that means that's a constant. What is the coordinate of alpha here? A. So we take H, G, A, this in this order. Second coordinate, constant. First coordinate, coefficient. I'm sorry. These are all coefficients. We are taking coefficients of alpha beta. The first alpha will have h and g, coefficient of beta and constant, coefficient of alpha, then h. Okay. Second equation, Same. I take the coefficient of beta, that is b, then constant f, then coefficient of alpha is h, then repeat. See this, h, g, a, and I have repeated h again. B, f, h, again repeated b. This is the process we use in cross multiplication method. Cross multiplication is what? You have learned it in finding the area of triangle also we use sometimes. See, h into f minus b into g. Cross multiplication, isn't it? I am multiplying h into f minus, with red I am taking minus, with blue I am taking plus. So hf minus b into g. Next, gh minus f into a. ab minus, means with blue what should I have? Plus ab minus h into h. This is called cross multiplication method. Children, I repeat it because you are learning it for the first time. Let me repeat. See what I have taken. I'll go back and repeat. Yeah, I have taken the variable alpha, variable beta, and the constant. I have taken 1. Now the second and first equations both are in the standard form. Means ax plus by plus c is equal to 0 form, right? So I'm looking at the coefficients. What is the coefficient here? H. What is the constant? G. What is the next coefficient of A? Alpha? A. So I'm taking in this order, leaving the first one H, G, A, H. Alpha beta 1, H, G, A, H. Again, in the next equation also, what am I taking? Second coordinate, B, F, H, B. B, F, H, B. Now, I am going to do cross multiplication. With blue arrow, I take plus. With the red arrow, I take minus. H into F minus cross multiplication, isn't it? H into F minus B into G. G into H minus A into F. A into B minus H into H. Let's see how do I write it. Alpha by. See, I'm taking alpha first coordinate by. What is this? HF minus B into G. HF minus B into G. That is equal to beta by G into H minus F into A. Then constant, this is 1 by A into B minus H into H square. Is that clear, students? I repeat, H into F minus B into G with alpha, the first variable. When you are considering first variable, I am not considering its coefficient. I am only taking HF minus BG. Then beta, I am not taking H beta. I am taking G into H, F into A. When I am taking constant, I am taking the coefficients of these two, A into B minus H into H. A into B minus H into H. Let's see. Alpha by HF minus BG. I have just removed the brackets. Beta by GH minus FA or AF is equal to 1 by AB minus H square. Now from this and this, first and third, what do I get? Alpha is equal to, if I bring it here, it becomes HF minus BG by AB minus H square. 1 into HF minus BG is HF minus BG by AB minus H square. When I take beta, GH minus AF into 1, that is GH minus AF by AB minus H square. So, I got the value of alpha as well as beta, isn't it? So, these are my required coordinates. Therefore, the origin is to be shifted to HF minus BG by AB minus H square, which is alpha, comma, GH minus AF by AB minus H square, which is beta. Students, I request you to revisit this slide and learn the cross multiplication method of solving linear equations, pair of linear equations. Now, do you think whatever I speak will be correct? Why don't you check whether I have done it correctly or not? Whether this method also is giving the same result or not? I want you to just solve these two equations either by substitution or by elimination and check for yourselves whether this value of alpha and beta is the same that we got here and that you get there. Okay? Will you do that, students? Please check it. Okay. Now the result that is obtained can be used as a formula. Why? What did we take? We took a standard form of the second degree equation, and we found the value of alpha beta, to which the point, the origin is to be shifted. So this formula will help us in solving problems. Okay, only standard form or any equation. Let us understand how we can use this formula, or what transformation this formula also can be used. By taking an example, let us see. Find the point to which the origin is to be shifted by the translation of axis so as to remove the first degree terms from the equation 4x square plus 9y square minus 8x plus 36y plus 4 is equal to 0. Same, except for the equation, everything else is same as the theorem that we have done. So what is given? Let us compare the given equation with the standard form. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. A is 4. We get, and then h is, oh, h is missing, not there, h is 0. By square, b is 9. 2g is minus 8. See, comparing the equations of like terms. 2gx minus 8x. 2g is equal to minus 8. So 2g is minus 8 by 2, 4. 2f is equal to 36. So f will be equal to 36 by 2, 18. And c is 4. A is 4, B, H is 0. All the values that we have got. Now what is the point? Alpha beta, to which the origin should be shifted? HF minus BG by AB minus H square, comma, GH minus AF by AB minus H square. We have seen this formula just now, isn't it? We will substitute the values. What is H? 0. So this becomes 0. Minus B into G, minus 4 into 9, minus 36, minus of minus, it will become plus 36. AB, 9 4s are 36, minus H square is 0. Oh, 36 by 36. It's 1. GH, H again becomes 0. AF, 72 and minus 72. AB minus H square. What is AB? 36 minus H square is again 0. Substitute 0 into 18 minus B, 9 into minus 4, AB minus 4 into 9 minus 0 square. Same, G into H minus A into F by AB minus H square. Simplify. 9 4 0 minus 36, that is 36 by 36, and then 0 minus 7, you get 1 comma minus 2. 36 one time and 2 times it is 72. Therefore the origin is to be shifted to 1 comma minus 2, so as equation 4x square plus 9y square minus 8x plus 36y plus 4 is equal to 0. Students, what did we notice? We noticed here that h is equal to 0. So we have discussed. And what is the value of a and b? They are not equal. But when h is equal to 0, what will happen to this formula? This becomes a 0. This becomes a 0. Oh, b and b get cancelled. What is left? Minus of g by a. This becomes 0. This becomes 0. A and a get cancelled. What is left? Minus f by b. So if h is equal to 0, alpha beta will be minus g by a comma minus f by b. This can also be utilized in your competitive examinations as shortcut method, wherein you find h is equal to 0. Don't do all the calculations. Just go for minus g by a and minus f by b to find the point to which the origin is to be shifted. Students, hope you have. Is not just, it's not story that you listen and leave it, isn't it? Whatever we have learned, I'll revise once and give you some practice sessions as well. What we have learned today? We have learned if the origin is to be shifted to h comma k by translation of axis, then we use what? Small x is equal to capital X plus h, small y is equal to y plus k, to find new coordinates to old coordinates xy on the transformed equation of the original equation. We have seen this. If you want to find the transformed equation from original, so you substitute small x, small y values, isn't it? If you want to find the new coordinates, you substitute the small values, small coordinates, that means small x, small y. You will get the new coordinates. Same way, we use x is equal to x minus h, capital Y is equal to y minus k, when to find the old coordinates and also to find the original equation when the transformed equation is given. We have seen this, children. Yes. Now, we have also seen the formula. What is that? The point to which the origin is to be shifted by the translation of axis so as to remove the first degree terms is from the equation is what? hf minus bg by ab minus h square, gh minus f by ab minus h square. This is also proved already, where h square is not equal to ab. What is the other note that we have seen? When h is equal to 0 in the to remove the first degree terms, the origin should be shifted to minus g by a minus f by b. This is the point, required point. Okay, students, now it's your turn to take some questions for practice. Very simple questions, as Krishna Kumar sir was saying, isn't it? This is a very easy chapter and you can score marks. 4 marks questions will be asked. When the origin is shifted to minus 1 comma 2 by translate equation. You know, already you have done. And if the given equation is already transformed, when the origin is shifted to minus 1 comma 2, find the original equation. Now the third question, the point to which the origin is to be shifted so that the point 3 comma 0 may change to 2 comma minus 3. Please understand the third question. The point 3 comma 0, that means that is the point in the original system, original coordinates. It has to change to 2 comma minus 3. So it is capital X, capital Y. What are you asked? Find the point to which the origin is to be shifted. You have to find h comma k. So h is equal to small x minus capital X, y, k is equal to small y minus capital Y. You can use that in order to find the value of origin, that is new origin h comma k. Now, before concluding, students, I'm really thankful to you for giving me, for having a patient hearing and for giving me this opportunity. As you are there in first year, I'm able to teach this, right? Thank you so much. Make best use of your time and solve all the questions that are given in your textbook. I also have to thank many other people, right? I have to mention my special thanks to Sri S. Satyanarayana Garu. He is TGT Mathematics from TSMS Chigurumamidi, who has been taking a lot of pain in preparing the PowerPoint presentation and helping me technically. Thank you so much, sir. And I have to thank many other people who have been instrumental in making this happen. Thank you so much. Dear children, transformation happens layer by layer, never all at once. So let's look for another layer in our next session. We will discuss about rotation. Thank you so much.
Thank you, madam. It was an excellent session. We all enjoyed it to the core. So your transformation in the children has begun, and I'm sure it will take them to the higher levels. So thank you very much, madam. Thank you.
Thank you, sir.
Thank you.